So for this one, on cosine and sine, the amplitude is the number in front of the equation, and the period is 360 divided by the number next to the theta, so divided by 3, which is 120. Now when you go to graph it, you're just going to put this in your calculator, just like that, with an x instead of a theta. And you're going to set up your table from 0 to 360 up by 30, because each of these tick marks are 30. And then when you go to your second table, you're going to start at 0 and go up by 30, and you'll see all your points. So when you see your 0 point, it's going to be 4. Your 30 is going to be 0. Your 60 is going to be -4. The next one is 0, and then +4, and these follow a little pattern. -4, 0, +4, 0, -4, and 0. And then you just connect the dots and make sure you make them round. Bear with me, I've got Apple pencils, so let's see if I can do it. And that's what your graph looks like. Number 2, your amplitude is 1 because there's a the number in front of the cosine is implied to be a 1. Your period is 360 over 2, which is 180. So every 180 degrees, you're going to get a full squiggly, a full rotation of the graph. So then you put it in your calculator using y equals cosine of 2x. Your table is going to be the same as the last time. And so then you've got 0 is 1. Then 30, wait a minute, the one between here is -1. This is flatter. And then this top 180 is 1. And then you go down here to between 240 and 300 is -1. And then 1 up here at 360. And then you just gently make your curve. And these have arrows going in each direction. This next one's also a sine, so your amplitude is 2, and your period is 360 divided by 1/2, because the number in front of this is a 1/2, which is going to be 720. And when you key it in the calculator, it's going to take 720 degrees. And this 180 is at 2, because that's the amplitude. Then 360 is at 0. And then 540 is at -2. And 720 is at 0. And 900 is at 2. And then it's at 0 again. So this is going to go like this. And we're done. This next one is amplitude is 2, so it's just going to go up 2 and down 2. And the period is 360 divided by 1/4, which is really 4 times 360, which is 1440 degrees. So it's going to take 1440 degrees right here to make a full squiggly. So let's see what happens. So at 0, it's 0. At 360, it's 2. At 720, it's 0. At 1080, it's -2. And then 0. And then +2. And 0. And then we just make our curve. This is an easy part of the test. Don't get it wrong. Now, for these last 4, they're not cosine and sine, so the amplitude is none, and I want you to write that down, amplitude none. And for secant, the period is the same as sine and cosine. Remember, they're the cousins. It's 360 over 1/2, which is 720. And when we're keying this in the calculator, it's going to be y equals 2 upstairs, and downstairs is going to be cosine of 0.5 theta, or 1/2 theta, if you want to do it that way. That's how you would key it in. And these are going to look like U's. If they do not look like U's, then you're doing something wrong. Cosecant and secant look like U's. So here, we're going to put this in the calculator. So these give you decimals, and don't be afraid of the decimals. 0 is 2, which is not a decimal, and then 90 is 2.82, so that's a little bit higher here, almost at 3. And then you've got your asymptote here. So you draw it on the next line. And remember, this kind of hugs the asymptote and goes up like a U, like that. And it should look like what your calculator looks like. So if it doesn't, you've got a problem. So now we're going to go to 270 is negative 2.82, which is here. And then we've got a 2 at 360 and another 2.8, negative 2.82. And then we draw our asymptote right here. Well, that doesn't look like a full U, so you can go ahead and make it a U. Just don't cross over the asymptote. And then the same thing happens on the left. The 630 is 2.82, which is here. And then a 2, and another 2.82, and another asymptote. And so here this is going to go like this. And you can keep going if you want. There's this little one down here, negative 2.82, and negative 2. And this one is going to look like this because it's half of a U. And we're done. So here the amplitude is none, because remember, none of these have amplitude. So once you get to these second ones that are not the sine and cosine, don't get tricked into that one. And your period is 360 over 1/2, which is 720. I'm sorry, it's playtime for the dogs. Let me turn the computer off for a while. So here, I like to do this. I like to put the 1 upstairs and the 2 downstairs, because 1/2 is numerator denominator. And then cosecant turns to sine, and then 0.5 theta, or 1/2 theta. So that's what you're going to key in your y equals screen. And you're going to go from 0 to 180, up by 90. And on the other one, you're going to do x minimum is 0, x maximum is 180, and the scale is 90. And your -6 to +6, minimum, maximum. And then you'll get all your points that you need. Well, this one right off the chute starts with an error at 0, so your asymptote is going to be right at 0. And then we're going to get 90 is 0.7071. And so that's this point here is right a little over half. And then it's going to be 0.5 right here at half. And then another one at 0.7071, a little bit lower. These are really close. And then this next one. So these are very wide U's that go like that. Then for the next one, you have that error. And then you got negative 0.7071, so negative a little over half, then negative 1/2, and negative almost a half, and then another asymptote. And there's your second U. That is a full period, but you can keep going. 720 is an error, and then it's 0.7071, 1/2, and that, and another error. And this one, this U goes like this. And that is your graph. So tangents also have no amplitude. None of these have an amplitude. Do not get that wrong. That's 1 point. But your period is 180 over 1/2. And that would be 360. Don't forget that it changes. You've got a formula sheet. Use it. And each one of these tick marks are 45. So when I set my window up, I start at let's start at negative 180 and go up by 45, and that'll give us one full squiggly, because negative 180 to 180 is 360, so it'll give us a full squiggly. So at 180, there is an error message at negative 180, and then it's negative 9.657. Well, that's going to be way down here, like right here. And then it's going to be -4. Hold on, right here. And then -1.67. And then we're going to have a 0. And then we're going to have a 1.67. And a 4. And then that 9 one way up here. So this is going to look like a little curve like this, and then curve back this way. And your 180 is going to be an error message like that. So cotangent, we're going to put the 2 upstairs on the y equals screen and put a tangent downstairs of 0.5 theta. And because there is no cotangent button, we're going to put that in the calculator. And this one has amplitude is none, and period is 180 divided by 1/2, which is also 360. So on this one, we're going to stick it in the calculator. So this graph goes all the way from -315 to +315 if you make each tick mark equal to 45. So I'm going to graph the whole thing so you can see what happens here. So -315 is 4.82, so it's up here, and then it's a 2, and then it's a 0.82, so not quite 1, and then it's an error. But this graph, if you look at the calculator, it's just an error at one point. The graph kind of goes through that point. So now we're going to go negative 0.82, which is here, and -2, and -4.82. So the graph still comes through here, but here there's a donut where it's discontinued. And now we're going to keep going. We get an error at 0, so there is a real asymptote there. And then we get 4.82 up here. And then we get a 2. And then 0.82, which is right here. And then we get an error here. That's another donut. -0.82, -2, and -4.82. So this is going to go like this with an asymptote. Not an asymptote, just a point of discontinuity. So if when you graph in the calculator, it doesn't look like it's hugging an asymptote, you just put a little donut at that point. And that's the only one like that on this test. Good luck, guys. See you in January.